Hi guys, in this video I am talking about back titration as requested by some of my students. So this is a really nice question where we are using a certain amount of a sample of FeOHN which is mixed with 20 centimeters cube of 2 moles per decimeter cube HCl, and enough water is added to make it to 200 centimeters cube of a solution A. Okay, and we're given the reaction equation as follow. So then what we're doing is we're taking 25 centimeters cube of this solution A and we are titrating it against this much amount of KOH as per this next equation, and we need to figure out the value of N. So let's first understand how we're going to go about this particular question. And to simply get this straight, we are working out the something unknown about a reactant in our original reaction or original solution. And so this is a typical back titration question where we are using our titration equation or titration measurements to work backwards and figure out how much of HCl would actually react with FeOHN. Okay, so when we are dealing with such a question, we often work in terms of number of moles. So let's start by working out the number of moles of potassium hydroxide. Okay, so we are given 2 bits of information. Okay, so we can say that number of moles of KOH is equal to its concentration times by the volume and divided by 1000 as we want it in the correct units, and that would give me a value of 1.456 times 10 to the power of minus 3 moles. So now when you're reacting KOH and HCl, they are in the same ratio. They are of the ratio of 1 to 1. So KOH and HCl 1 to 1. So the number of HCl moles which are reacting with KOH are also this exact same. Okay, so we know that this is reacted, and these number of moles are present in 25 centimeters cube of solution A. Okay, so we have to work out how many moles will be present in the original solution of A, and we know that that's 200 centimeters cube. Okay, so therefore in 200 centimeters cube of solution A, we will have 1.456 times 10 to the minus 3 divided by 25 centimeters cube and times by 200. Okay, so this is just simply a dilution situation where we're working out the original amount of moles, and this is going to give me 0.011648 moles. Okay, so now we know that this is the amount of moles in solution A in 200 centimeters cube, and now we can figure out how many moles of HCl will be reacting. But first we have to think about how many moles of HCl were present in the original solution to begin with. So for that I have this number right here, which I am going to use to calculate the original number of moles of HCl. So HCl originally present is going to be the concentration times by the volume, so that will be that, and that will give me 0.04 moles. Okay, so that means that the number of moles that would actually react with this iron hydroxide compound, which is a solid, will be this particular number here, original, minus the number that we're reacting with, obviously, KOH. Okay, so let's find that out first. So I'm just gonna zoom out slightly. All right, so number of moles of HCl remaining, or would end up reacting with FeOHN, will be 0.04 minus 0.011648. And let's see what that gives me. So 0.04. Okay, so that gives me a value of 0.028352 moles. Okay, so now we know that the ratio of FeOHN to HCl is 1 to N. Okay, so 1 to N. So that means that the number of moles of FeOHN is going to be 0.028352 over N. Okay, remember we can use proportion method for this. So now that we have the number of moles, I know it's in terms of N, but we can still work with it. We have that with us, so now I would use the basic formula of N equals M over Mr and rearrange to work out the mass, okay, in terms of N. Okay, sorry, the molecular mass in terms of N. So let's put that right here. So we've got the number of moles, so Mr is equal to, that is a bit too thick, so let's go for that, is equal to the mass divided by the number of moles, and mass is given to us as 1.0101 over the over the N, which is 0.028352 over N, and that gives me something in terms of N, which is 35.63 N. Okay, so I know it's in terms of N, but if now we look at the actual molecular formula, which is that of iron, iron I believe is 56.5 or 56 basically, sorry. So 56 plus the oxygen and the hydrogen, which adds up to 17. Okay, so N is equal to 35.63 N. And after rearranging that, we will end up getting N as, let's see, so okay, right. So that ends up giving me a value of 3 for N. And there you have it. So you can work out unknown things such as the molecular mass or the percentage purity of a reactant, which could sometimes be hard to work directly out, and hence we use back titration to determine the amount of substance. And we reacted with an excess known amount. In this case, it was HCl. So that's the idea behind back titration, and hopefully this has helped you to some extent. And let me know in the comments below if you have any questions. Thanks very much for watching.